All right, Unit 6, Lesson 6, the second part of Pythagorean identity. And remember that Pythagorean identity with, well, the identity itself is sine squared theta plus cosine squared theta. And actually, I'm going to rewrite that as cosine squared because normally we write our x value first, like when we're writing a coordinate pair. So we'll write it this way. But again, it doesn't really matter which way you write it. So cosine squared plus sine squared equals 1. That is our Pythagorean identity. So taking a look at 6.1, for an angle theta in the quadrant indicated, use mental estimation to identify the values of cosine, sine, and tangent as either positive or negative. So remember in quadrant 1, well, and let's remember that cosine of theta is our x value, and sine of theta is our y value. And then tangent is our y over x, because it's the same thing as sine over cosine. Okay, so if we have quadrant 1, everything is positive, right? Because our x values are positive, our y values are positive, and a positive divided by a positive is a positive. All right, in quadrant 2, our x is negative, so cosine of theta is negative. Our sine is y, so that's positive. So sine of theta is positive. And when you divide a positive by a negative, you get a negative. So tangent, not equals, is negative. All right, quadrant 3, sine and cosine are both negative. Remember, because our x and our y are both negative in quadrant 3. And then when you divide a negative by a negative, you get a positive. So tangent of theta is positive. And then in quadrant 4, we have cosine is positive, but sine is negative because y is negative. And then tangent is also negative because you have a negative and a positive being divided. So sine and tangent are negative. One way you can remember that is if you draw the coordinate plane. So you can say all positive, right? And then here we've got cosine and tangent are negative. Sine is positive. We've got cosine and sine are negative. Tangent is positive. And here, cosine is positive. And then sine and tangent are both negative. All right. Okay, so let's take a look at Andre's calculations, part 2, or 6.2. Suppose that the angle theta in radians is in quadrant 4 of the unit circle. So again, I'm a visual person. I really like to draw this out so that I can see what I'm doing here. All right, so it's in quadrant 4. So we have this triangle here, and we know our cosine is 0.28, so that's our x value. We don't know what our sine is, but we do know that our hypotenuse is 1 because it's a unit circle. So this ordered pair is 0.28 something. We don't know what that something is. Andre uses the Pythagorean identity and determines the value of sine of theta is negative 0.96. Well, the negative makes sense because y values are negative in the fourth quadrant. Using the values of sine and cosine, he then calculates the value of tangent. And so then you can see his work. Do you agree? So let's take a look at the Pythagorean identity. So we have, remember, it's cosine squared of theta plus sine squared of theta equals 1. That's just Pythagorean theorem using sine and cosine. All right, so we know that the cosine value was 0.28, and then we don't know what sine is, so we're going to figure that one out, and then that equals 1. All right, so we're going to break out a calculator because sometimes doing those decimals in our heads can be a little challenging. What just happened here? Oh, it changed. I thought I tapped on it, but it changed on me. All right, so I'm going to do 0.28. Oh, didn't catch my decimal point. There we go. Squared. So that's 0.0784. And then to move that to the other side, I'm going to subtract from 1. So 1 minus that answer gives me sine squared of theta equals 0.9216. So then we need to take the square root of both sides. And again, that's going to be plus or minus. And in this case, it is negative because we're in the fourth quadrant. So I'm going to take the square root of that. So let's square root of that answer. And that gives us 0.96. So he did the Pythagorean identity correctly. And then he went up here, and we know that tangent of theta equals sine over cosine. So he plugged in those values. That makes sense. And then let's just check that. So let's do negative 0.96 divided by 0.28. Oops. 28. There we go. And yep, that's the same thing. So yes, I agree. And the tangent has to be negative because we're in the fourth quadrant. So yeah, that looks good. So we're going to say, I agree. And then some of the things that we just talked about, you know, since theta is in Q, whoops, that looks like a theta, Q4, sine of theta is negative, and tangent of theta is negative, right? And we showed that work, right? So that's part of our showing our reasoning, was using that Pythagorean identity to look at that. All right, so the last thing is a card sort. And so let's just take a look at the cards, and we are going to match them, find two pairs that are possible in the unit circle and two pairs that are not. So let's just take a look at what these cards look like, and we'll just do a few together. All right, we don't need that anymore. All right, let's make this bigger. All right, so, and there's the summary for later if you want to take a look at that. So here are all the cards. All right, so let's take a look at these cards. And so we have a set of cards that have sine, cosine, and tangent values. And then we have cards that have quadrants. And ideally these would be, you know, cut up, but this is digital, so we can't do that. All right, so if I say, okay, so first we're gonna identify two pairs that are possible in the unit circle. So if I look at sine of 0.5, I'm gonna say that that can be in quadrant 1 because sine is positive in quadrant 1. If I do cosine of negative 0.8, that can be in quadrant 2 because cosine is negative, x is negative in quadrant 2. But if I say, all right, sine of negative square root of 3 over 2, and I say quadrant 2, that cannot be possible. That's why I made it orange. So the blue is possible, the orange is not possible. Because sine is y value, and y value is not negative in quadrant 2. Let's see, tangent is positive 1. So tangent is only positive in the first and the third quadrants. So if I say quadrant 4, I am wrong because in quadrant 4, tangent has to be negative. All right. So then we're going to take one of our possible matches, which are the blues, and we're going to calculate the values for the two missing trig ratios that match. So I'm just going to go with the first one, the sine, which is 0.5. So let's do, so sine of theta is 0.5. So, and that's in quadrant, we said quadrant 1. I probably should have color-coded them. Let's do this. I'm going to do this. That way they're color-coded. All right. So the green and the blue are possible. The orange is not possible. Or I guess let's put those back and make those numbers. So we did that one first. We did that one second. We did this one third. And we did this one fourth. Okay. All right. So we're looking at that one in quadrant 1. All right. So we can say, all right, so cosine of theta, or cosine squared of theta, plus our sine squared of theta equals 1. So cosine squared theta plus 0.5 squared equals 1. So cosine squared theta plus 0.25 equals 1. So cosine squared theta, and do we have to do the exact value? It doesn't say exact value, so that's fine. Let's see. So we're going to subtract that 0.25, so that equals 0.75. And then take the square root. And since we're in quadrant 1, it's going to be positive. So cosine of theta equals, you know what, we're just going to leave that as the square root of 0.75 because that is an irrational number. All right, so there's my cosine. Now we need to find tangent. And remember that tangent is sine over cosine because sine is the same thing as the opposite when we're on the unit circle, and cosine is the same thing as adjacent when we're on the unit circle. All right, so our tangent is equal to 0.5 over the square root of 0.75. I'm going to change these to fractions because it might help us to see something a little bit differently. Plus, when you move into higher levels, you will see that we tend to use fractions. All right, so the square root of 3 over the square root of 4 can actually be rewritten as the square root of 3 over 2, right? And they both have 2 in the denominator, so that's the same thing as 1 over the square root of 3. Typically, we don't write that way. We rationalize it. So how can we get rid of that square root in the denominator? Well, if I multiply by the square root of 3, I'm making it a perfect square. So then when I multiply it together, I get rid of that radical, but I can't just do that. I have to multiply the numerator, so that way I'm essentially multiplying by 1, right? So that actually becomes square root of 3 over the square root of 9, which is 3. So that is my tangent value. All right, that's just one example of how you can find the other values using your Pythagorean identity, and then the fact that you know that tangent is sine over cosine.